Going over the mesh study, let's add the 50mm sizing to the body and 10mm to the body of influence. And now what we should do is just right click and preview the surface mesh. It looks pretty decent around the main body. However, around the wheels we can see that the mesh is too coarse and hasn't captured the features. We can then incorporate a face sizing along the wheel of 6mm and around the fillet of around 2mm. Preview that. So checking that area, it looks as if the mesh has appropriately captured the geometry. Let's go through and check the results. We can see that we have few elements of low quality. Let's go and generate the mesh. Again, going back and checking the quality, we can see a few elements with a low quality. So what we can do is incorporate inflation. So let's go back and unsuppress the inflation. Now it's inflated the fairing as well as the wheels, but it hasn't inflated the fillet that has been created. So let's go through and check that. We have a message saying that the inflation has created a stair-step mesh at some locations. So looking at the mesh, it looks as if we've inflated around the top of the fairing. We've got this stair-step mesh towards the fillet. Now checking the quality again, we can see that the minimum quality has dropped quite a bit, with most of the actual poor quality elements around the wheel. There's not much you can do due to the actual geometry and the way that the mesh is created, and there are times where you'll just have to run the mesh, and then if there are any issues, we'll have to come back and improve areas along these elements. And the next step is inflating the floor. So what we're going to do is put an inflation on the floor. However, because the two inflation regions are connected to each other through that fillet, we need to have the same amount of layers. But if we do that, due to the size of the fillet, we'll have some errors. So what we're going to do is create a third inflation along the fillet. We're going to give it 14 layers, smooth transition ratio of 1, but give it a growth rate of 1 as well. So again, looking at the mesh, we can see that we've got the 14 layers that then has to transition very rapidly to take the corner around the fillet, and then the ground inflation layer can be seen. Due to the geometry change and the meshing technique that was used, we're going to have very poor elements around that surface. These might cause errors within the simulation. However, as they're not a large part of the fairing itself, it shouldn't cause any divergence. Now let's unsuppress the other domains and let's incorporate the edge sizing. So as before, we want to incorporate edge sizing along the whole inlet domains. So we can see that we've got 30 divisions. We've got 9 edges that are highlighted at the inlet. We've got elements that create a smooth transition. So what we can do is preview that mesh. Now as we can see, we've got elements that are around 50mm, which lines up with the body sizing that's previously been created. So we can go through and then incorporate edge sizings. So we've got the edge sizing around the wake region, above the fairing, so select all edges above the fairing, towards the outlet, and we've got the edge sizing through the thickness as well to think about now. Then go ahead and generate the mesh. Now that the mesh has been created, we can go through and check the quality to make sure nothing's changed. So we've still got a few low quality elements around the tire and the ground, which was as expected due to the geometry and also the meshing technique. We can see that we've got a smooth transition. Now exit the simulation. As the setup should be ready, all you should need to do is set up and let the solution run. Plotting the residuals, you can see that after an amount of time, the residuals have settled with a little bit of oscillation, which can be fixed by changing the current number if there are any issues. However, looking at the plotted data, We can see that the monitors for lift and drag have stabilized. Now let's go into post.